Hello there, I'm Ethio-Hahu, and let's solve this problem. The square root of 2 minus logarithm of 9 to the base x is equal to minus radical 12 over logarithm of x to the base 3. Find x. To find the value of x, let the square root of 2 minus logarithm of 9 to the base x is equal to minus radical 12 over logarithm of x to the base 3. Squaring both sides, the square root of 2 minus logarithm of 9 to the base x square is equal to minus radical 12 over logarithm of x to the base 3 square. This implies minus 1 square times radical 12 square divided by logarithm of x to the base 3 square. This implies these two cancels this. We have 2 minus logarithm of 9 to the base x is equal to minus 1 square is 1. These two cancels this. We have 12 over logarithm of x to the base 3 square. Multiplying both sides by logarithm of x to the base 3 square, we have logarithm of x to the base 3 square into 2 minus logarithm of 9 to the base x is equal to logarithm of x to the base 3 square into 12 over logarithm of x to the base 3 square. Logarithm of x to the base 3 square by logarithm of x to the base 3 square cancels. Here we have logarithm of x to the base 3 square times 2 is 2 times logarithm of x to the base 3 square minus logarithm of x to the base 3 square times logarithm of 9 to the base x is equal to 12. This implies twice of logarithm of x to the base 3 square minus logarithm of x to the base 3 times logarithm of x to the base 3. Logarithm of x to the base 3 square means logarithm of x to the base 3 times logarithm of x to the base 3 times logarithm of 9 to the base x is logarithm of 3 square to the base x is equal to 12. This implies 2 times logarithm of x to the base 3 square minus 2 times logarithm of x to the base 3 times logarithm of x to the base 3 times logarithm of 3 to the base x is equal to 12. This implies 2 times logarithm of x to the base 3 square minus 2 times, here 3 cancels by 3, x cancels by x, we have logarithm of x to the base 3 is equal to 12, because logarithm of x to the base a is equal to 1 over logarithm of a to the base x. Multiplying both sides by logarithm of a to the base x, logarithm of a to the base x times logarithm of x to the base a is equal to, multiplying this by logarithm of a to the base x cancels by this, we have 1. this is 1 times logarithm of x to the base 3 is logarithm of x to the base 3 times 2 minus 2 logarithm of x to the base 3 is equal to 12. Dividing both sides by 2, by 2 1, by 2 1, by 2 6. Logarithm of x to the base 3 square minus logarithm of x to the base 3 is equal to 6. Logarithm of x to the base 3 square minus logarithm of x to the base 3 is equal to 6 means logarithm of x to the base 3 minus logarithm of x to the base 3 this square minus 6 is equal to 0. Let y is equal to logarithm of x to the base 3. Hence, logarithm of x to the base 3 square is y square minus logarithm of x to the base 3 is y minus 6 is equal to 0. Let's find two numbers whose sum is minus 1 and whose product is minus 6. These numbers are minus 3 and 2. Therefore, y square plus 2y minus 3y minus 6 is equal to 0. From this, take y as a common factor, y into y plus 2. Here, minus 3 is common. We have y plus 2 is equal to 0. Minus 3 times y minus 3y minus 3 times 2 minus 6. Again, here we have y plus 2 and y plus 2 as common factor. Y plus 2 is taken as common factor into, here we have y, here minus 3 is equal to 0. Therefore, y plus 2 is equal to 0 or y minus 3 is equal to 0. This implies y is equal to minus 2 or y is equal to 3. Now, when y is equal to minus 2, logarithm of x to the base 3 is equal to y. This implies logarithm of x to the base 3 is equal to minus 2. This implies x is equal to 3 to the power of minus 2 is equal to 1 over 3 square, which is equal to 1 over 9. Therefore, x is equal to 1 over 9. When y is equal to 3, logarithm of x to the base 3 is equal to y, which is equal to 3, and this implies x is equal to 3 to the power of 3, which is equal to 27. Therefore, x is equal to 27. But for this function to be defined, the number under radical has to be greater than or equal to 0. But for this to be defined, for the square root of 2 minus logarithm of 9 to the base x to be defined, 2 minus logarithm of 9 to the base x has to be greater than or equal to 0. And let's take this to the right. 2 is greater than or equal to logarithm of 9 to the base x. This implies logarithm of 9 to the base x is less than or equal to 2. And this implies x squared is less than or equal to 9. And this implies absolute value of x is less than or equal to 3. And x is less than or equal to 3 and greater than 0, because x has to be greater than 0 and non-negative number for this logarithm to be defined. Absolute value of x is less than or equal to 3 means x is less than or equal to 3 and greater than or equal to negative 3, but this logarithmic function cannot be defined for negative number. Therefore, we ignore the negative part and x is greater than 0 and less than or equal to 3. With this, x is equal to 27 cannot be the solution. Therefore, the solution is x is equal to 1/9. And this is all about this exercise. Next time we'll do similar problems. Until then, have a nice time.